This video is going to cover the graphing calculator as well as how to find intervals of increasing, decreasing, and then there's some other review built in. So before I graph anything, I'm going to determine the end behavior. The lead coefficient is 2 and the degree is odd. Odd degree and lead coefficient is odd. Sorry, the lead coefficient is positive. Odd degree, lead coefficient is positive. This has down, up, end behavior. So as x approaches positive infinity, y approaches positive infinity. And as x approaches negative infinity, y approaches negative infinity. This is the left-hand side. The left represents negative x values, negative infinity, and y is going down. Okay, so I'm going to review how to plug this into the calculator. If you don't have a graphing calculator, do your best to get one as soon as possible. Okay, so a couple things. When I type into the graphing calculator, I need the y equals. That's where all of my equations go. The x key, this is the variable key, x, t, and then that fancy O, which is theta, it's Greek, n. The caret key, which is going to help you type in exponents. And then the negative key, which is not the same as the subtraction key. The calculator distinguishes between the two. So here's the negative, which you can see is not quite as long, and then the subtraction key. Okay, so I'm going to type in 2x cubed plus 6x squared minus 3. So I'm going to let me put here y equals. I have an extra equation in my calculator. You don't need to worry about that. So 2, I'm just going to push the number 2, x, which is the variable key, caret 3. Make sure you use the right arrow key so that you're no longer hanging out in the exponent of the previous term. Plus 6x, and you can either use the caret key for squared, or you can use the x squared key, which is near 7. And then subtract 3. I want to see what the graph looks like. I'm going to push graph. And the end behavior is indeed down, up. Okay, so I'm just going to go in order that the table is. So the next thing we're asked to find are the x-intercepts. And I'm going to find these before I draw the graph. That way I can draw a more accurate graph. Remember that the zeros are where the graph crosses the x-axis. Second trace, that's where all the menu lies. Second trace. I can calculate a 0. Here's my minimum, my maximum. So I want to calculate the 0. So either arrow down or push the number 2, push enter. All of these, whether you're finding the max, the min, or an intercept, they're all going to ask you for a left bound. So I'm going to use my right arrow, and I'm going to go, in this case, to the left of the 0, which is the same as going underneath. Doesn't matter how far you want to go, further. You want to go as close as you want. It makes no difference as long as you are underneath the intercept. Push enter. Arrow to the right. Arrowing how high you want to go, it doesn't matter as long as you are above the x-intercept. Push enter. Guess means guess where you think it is. Well, whatever, I'm just going to guess that it's here. Push enter, and there is the 0. It's at negative 2.8. This is going to be negative 2.8-ish, 0. Okay, that's one of them, but remember there's 3. The degree is 3. There should be 3 of them. And if you look at your graph, there's 1, and then there's another one around negative 1, and then there's another one around positive 1. Do it again. Second trace. Number 2, find the 0. Okay, so I'm going to go to the left of the intercept. In this case, that's above. Push enter. Arrow to the right, somewhere below. Push enter. And then try and get your cursor as close as you can, wherever, doesn't matter. Push enter. And this is at negative 0.8 comma 0. It might be a little bit off compared to me. That's okay. So that's 2 of them. 1 more. All right, do it again. Second trace, 0. Arrow to the right. Enter. Arrow above. Enter. Guess, just get as close as you can. Enter. And that last 0 is at 0.6. Okay. The y-intercept, we don't need the graph. The y-intercept, make x 0. So if x is 0, you end up with negative 3. Okay, so I'm just going to kind of sketch these points. It's about negative 3-ish, 1, 2, negative 3-ish, negative 1-ish, half-ish, and then negative 3, 1, 2. Okay, not going to graph yet until I figure out where the turning points are and the maxes and the mins. A turning point is either a max or it's a min. By definition, it's either a high point or a low point. So turning point is where the graph switches direction. It switches from going up to going down. So in this graph, we have 2 turning points. The graph is increasing, increasing, increasing until it hits this top point, which is a max. Then it's decreasing, 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 decreasing until it hits this point, which is a min, and then it increases. So let's find the max, let's find the min, and those will also be my turning points. So again, second trace, I want to find the maximum, number 4. I'm going to use my right arrow key. It's going to ask me to see how it asks me for a left bound. I know that's hard to see in the video. Enter, arrow to the right, get on the other side, enter. Depending on your calculator, you will see that I've got at the very top of the screen here, I've got an arrow pointing left and an arrow pointing right. And what the calculator is going to do is it's going to find the maximum point between those 2 dotted lines. Guess means get as close as you can. And the maximum, we're just going to round and say it's at negative 2 comma 5. So the maximum is at negative 2, 5. And that happens to also be a turning point. Negative 2, 1, 2, 3, 4, 5. Okay, the minimum, second trace, minimum either arrow down or push the number 3. And again, here's this whole right bound, left bound thing. Go to the left of that minimum point, push enter. Go to the right, push enter. If you want to go higher, fine. And then guess, I'm going to just arrow and try and get on top of it. And is indeed at the y-intercept, 0, negative 3. So that's also a turning point. Turning points, all maxes and mins are turning points. A maximum is a more specific turning point. Okay, so now here's my graph. And I'm going to just try and sketch this. Good enough. Good enough. Okay, so now I've got this whole increasing, decreasing things. So increasing and decreasing, what is happening to y what's happening to y as x goes from right to left. As x moves from negative infinity to positive infinity. Okay, well, you've already answered all these questions. You've already answered all these questions. Down here is negative infinity. So as I'm moving across to positive infinity, what's happening to y? Okay, well, when x is negative a gazillion, my graph is way down here. And then y is increasing and y is increasing and y is increasing and y is increasing until it gets to this point right here, which we decided was negative 2, 5. So from negative infinity all the way until I get up to negative 2, y is increasing. From negative infinity as x is getting closer and closer and closer and closer to positive infinity. So when x is negative 4, y is negative something. When x is negative 3, y is negative something. When x is negative 2, y is 5. So this graph is increasing, climbing up until x is negative 2. So it is increasing from negative infinity to negative 2. It's not an ordered pair. You don't say that it's increasing from negative infinity until 2, 5. No, your answers are only x values. These are my x values. It's an interval. Then once I hit negative 2, when x is negative 2, right here, my graph is going down. So my graph is decreasing from the time x is negative 2 until the time x is 0. So we're decreasing from the time x is negative 2, and we're going down, 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 down until we get x is 0. I'll explain the parentheses in a minute. Then after x is 0, when x is 1, y is a number. When x is 2, y is a bigger number. When x is 3, y is an even bigger number. When x is 4, y is an even bigger number. So from 0 all the way forever, the graph is going up. That's increasing. So from 0 till forever, the graph is increasing. Negative 2, 0 is an interval. Notice negative 2, 0 is not on my graph. So these are all x intervals. Okay, y parentheses. Okay, so we've talked about this before, that infinity, negative infinity are always parentheses. Infinity, negative infinity are always parentheses. Okay, and so are turning points. So turning points are also always parentheses, and here's why. Okay, so here's why. That says parentheses, it's not a C. When I get to this point, negative 2, 5, I'm increasing and then I switch to decreasing. I'm increasing and then I switch to decreasing. So at the point, negative 2, 5, what am I doing? Am I increasing? Am I decreasing? No, I'm switching directions. So I'm neither increasing nor decreasing. I'm switching directions. So have you ever seen, like, sometimes in the gymnasium when people are running to one end of the gym and they stop and they turn around and they run to the other end of the gym, and they stop and they turn around. At that turnaround point, you're not running anymore. You're stopping and you're turning around. So that's kind of how I look at it. Okay, so this is great for your notes. And then your homework is to complete the second sheet. Your homework is to complete the second graph, and then both should be turned in for today's asynchronous lesson. Turn in both pages for today's asynchronous lesson.